Okay, so 3, 2, we talked about logs. We talked about how to try to do like some mental math using the properties of logs. We talked about LNs, and then we graphed the logs, which is like number 3. So if you look at number 1, obviously I can go through the long process if I don't see it and say if this equals x, convert it so that it's 6x equals 36, change the base so it's 6x equals 6 squared, and then x equals 2, okay? But hopefully we get to the process in which we say, okay, what do I raise 6 to get it to be 36? And you avoid that whole process, and the answer is just 2. The idea here is that you want to get so good at these that obviously when we start getting into properties today, it's going to push it a little bit further. And then when we get into solving equations, it gets a little bit more complicated. You want to have this part down pretty good. All right, number 2 says rewrite the expression. So if I had changed the 1 over e to the 5th to have no fraction, what would that look like?
E -5.
Good. So it'd be 2 ln e to the -5. And then I can, again, go through the long process, rewrite ln of e as log base e of e to the -5th, right? But we said last week a way to make our lives a little bit easier is cancel through ln of e and keep the exponent. Now that means that exponent is now in place of it, which means this would be 2 times -5 or -10. So you don't keep the exponent like in an exponent, you keep it as the entire simplified expression. But again, long way around that would be 2 log base e of e to the -5th. Again, this cancels through keeping the exponent, and I would have had 2 to the negative times -5 anyways, and you should have gotten -10. Today we're going to even learn one more way to do this, okay? But they all should result in the same answer. Number 3, identify the domain, the range, the asymptote, and the x-intercept, and then graph the function. And actually, you don't have to do it in that order. I would have done y equals log base 5 of x plus 4. 5 comes over. Yeah.
For me, it says y-intercept.
Oh, okay. Change it, because that doesn't make sense.
Okay.
Yeah. It could have a y-intercept if there's a shift, but it won't always. So when I ask you about the log, it will change. It should say, anyways, the x-intercept. So I get this equals x plus 4, and then y to the 5th minus 4 equals x. And then remember, we plug in for the y when we do logs. So 5 to the -1 minus 4. 5 to the 0 minus 4. And 5 to the 1st minus 4. I get 1/5 minus 4, which is -3 4/5. 1 minus 4, which is -3. And 5 minus 4, which is 1. -3 4/5. -3 and 1. And then I go to my graph. Plot your points. So -3 4/5 and -1. -3, 0, and 1, 1. Remember, the asymptote comes from this expression here, which is also the horizontal shift. So my asymptote would be x equals -4. And then I know my graph kind of hugs that asymptote line and then points to the right. Domain here would be what?
-4 to infinity.
Good, with a parentheses on that -4, right? Because I can't include it. Range here would be what?
-infinity to positive infinity.
Good, Si. And then it should have been x-intercept. -3, 0. This time there is a y-intercept, right? But because you can't plug in 0 for x and get, you'd get log base 5 of 4. And that's not something you can do without a calculator. So I wouldn't ask you that kind of question. Yeah.
So when you're trying to find the variables, how would that process change if you didn't have parentheses around the x plus 4? So if it was a vertical change or shift instead of a horizontal?
So if it was y equals log 5x plus 1, let's say. Is that what you mean?
Yeah.
Okay, so you got to move the 1 over first. So it'd be y minus 1 equals log base 5 of x. Then the 5 picks up the y minus 1. And then you plug in. The vertical asymptote here would be x equals 0. Domain would be 0 to positive infinity. Range still the same.
Oh, so you don't include the plus 1 when finding the asymptote?
Nope.
It's not parentheses? Okay.
Nope, just the parentheses.
What about the shift? Why is it 0 to infinity?
Because that's a vertical shift, so it shifts it up, but the vertical asymptote would still be at 0.
Oh, the vertical asymptote. Okay.
Yeah. Good questions. Everybody else good? So as far as quiz goes, be thinking we didn't take out a calculator for any of these questions. These could all be fair game, right? You will get a graphing you're going to get a graph that is exponential without a calculator, a graph that's log without a calculator, and then probably for tests, which we're talking next week, we would have ln's and e's, or exponentials that are a little bit more complicated, okay? And then that way you have to use the calculator to plug those, or to find those values. But for the quiz, you will not use a calculator, and so they won't be calculator-based questions. All right, so 3.3 is called properties of logs. So we're just going to learn a couple other things today. We're going to talk about change of base. We're going to talk about expanding and condensing logs. All of this stuff should be review, but it's been a long time. So change of base is how we find the logs if the base is not a common log. So if it's not log base 10, how do I find out what that is using a calculator? If it's not ln, how do I find out what that is? And so it's called the change of base formula. And it basically just says that I can find the log of any base in any number by taking log of the top number, the big number that's here, over log of the base, and this base can be any log, which means we can use our common log. So I can say log itself of x over log of a, or I can say ln of x over ln of a. So this would be common log, because the homework's going to ask for it. Like rewrite it as a ratio of common logs, and then rewrite it as a ratio of natural logs. So remember, the little number next to the log is called the base, right? This is read as log base 3 of 23. Base goes in the bottom. So the big number by way of not value but physical size, 23 is written to be larger than 3. The big number goes in the top, the small number or the base goes in the bottom. So this is how you would find the log of something that you cannot have raised to a power, or is not log base 10. So if you take out a calculator and I want to find log base 3 of 23, I would literally do log base 10 of 23 divided by log base 10 of 3. Or you could do ln of 23 over ln of 3. Either way, you get the same answer, which would be 2.85. So again, just be careful. Like the big by way of size, not value. That bigger number, when we write out the log, goes in the top, the base goes in the bottom, and then you just divide. So example 1 says, rewrite the log as a ratio of A common logs and then B natural logs. Then use the calculator to evaluate the log and round it to 3 decimal places. So which is going in the numerator, 5 or 8?
5.
5. So A common logs would be log base 10, or just log of 5 over log of 8. B natural logs, ln of 5 over ln of 8. C, actually find this using one of those. So log of 5, if you're typing this in a calculator, like a graphing calculator, you have to close the parentheses after the 5. Divided by log of 8, and I get 0.7739, which is 0.774. You can check it with your ln. ln of 5, again, you have to close your parentheses, divided by ln of 8. I get the same answer. If you're using a scientific calculator, that does not store the words when you type it, for example, your phone, you have to do the order different. You have to do 5 log divided by, what's my other number? 8 log equals. If you don't have the equals at the end, you think you have the right answer. You do not. Okay? So make sure you know how to use both of those. So if you saw a question like this on Thursday's quiz, it would just ask you to write it as a ratio. It's not going to ask you for the last step. So it could say, write it as a ratio of common logs, write it as a ratio of natural logs. Obviously, you're not going to be able to do C, where you actually find it. So if you think back to like what we used to say, if I had log base 10 of 100, obviously I can simplify this without a calculator, right? 10 to what power gives me 100? It's 2. But now I can also have log base 7 of 3. You had no other way to find that before now. Now I would rewrite that as log of 3 over log of 7 and then use the calculator to find it. Does that make sense? Okay. All right, so 3 properties to logs: product, quotient, and power property. The product property says if I start with one condensed statement where it has 1 log in it, I can actually expand that product by rewriting it as the sum of the 2 logs. So a product goes to a sum when I expand. The quotient property says if I start with a quotient, as otherwise known as division, then when I expand that out, it becomes a subtraction sign or a difference. Top minus bottom. And then the power property says if I have a base and then something raised to a power, that power gets bumped to the front of my log statement. So you're going to see the words condense and expand, okay? These are expanding. We start with 1 log and we're expanding it to be more than 1 log. Then I can go vice versa the other way. Expanded to condensed, which brings it to 1 log. So product goes to sum, quotient goes to difference, power goes to the front of the log. So this says approximate the log using the properties of logs, given log base b of 2 is 0.3562 and log base b of 3 is 0.5646. So this is a way, again, to do the kind of questions that we just had, which is like change of base. I don't know what b is. There's no way to find log base b of 6, right? But what this is telling me is that I know log base b of 2 and log base b of 3. So can I rewrite 6 in terms of 2 and 3? What's the same as 6 in terms of 2 and 3? Say again.
Having the b, everyone has the b.
So the b stays there, right? How do I rewrite 6 using 2 and 3?
Do you just multiply both of those?
Okay, so 2 times 3 is the same thing as 6, right? Now, would we just say if I have it condensed into 1 and I want to break this apart, what do I do? If it's multiplication, it becomes?
Power.
Close. That's not a power, it's a product, right?
Yeah, add them together.
You add them. So this would become log base b of 2 plus log base b of 3. So when I expand and it started as multiplication, it becomes addition. You with me so far? Now, they already told me log base b of 2 is 0.3562 and log base b of 3 is 0.5646. And now I just have to add those together. And I get 0.9208. So there's
so
no...
we use a product property here?
Yep. So there's no other way to find that because I have no idea what B is, right? I can't find that using a calculator. You can't find that any other way other than breaking it up in terms of what they give you and then substituting it in. Okay,
Wait, so when we're plugging into the calculator, what are we putting in for the b? Are we just
you can't.
having log of 2?
No, you can't find this in the calculator.
Right, so how'd you get to the 0.3?
It's this one. So I took log base b of 2 and replaced it with what it told me it was.
Oh, that's all it is? Because you're right, because you can't put it into the calculator.
Exactly.
And then you don't use, and then your final answer is just the 0.9208?
Correct.
Okay.
So look at B. There's a couple of things happening here. The first is these are both raised to a power. What's the rule on the power product? The power property. Negative 3 goes to the front. So negative 3 log base B of 3B. Power goes to the front. Now I've got a product, yes? What happens when I split that product? Mm-mm. Not yet. What did we just do with the product when we broke it apart, when we expanded it? We made it addition. So this gets the same thing, except they both get the negative 3. So negative 3 log base B of 3 plus a negative 3 log base B of B. So negative 3 log base B of 3 minus log base B of B. Because they both had the exponent, when they split, they both get the number at the front. If it was log base B of 3 times B to the negative 3 and only B had the negative 3, then the second parentheses would only get that negative 3. But because they both were in the parentheses, they both get it. Okay, so then Victor, notice what? What can I do with the B and the B? This cancels and just becomes 1. So now I have negative 3 log base B of 3 minus 3 times 1. I get negative 3 log base B of 3 is given to me at the top. 0.5646 minus 3. So 0.5646 times 3. 1.6938 negative minus 3 negative 4.6938. I think those are the hardest things of the whole section, to be very honest.
Agreed.
The rest of it is just expanding and condensing, okay, without having to plug actual values in. Questions before I move on? Anybody still copying it down? All right, so now we're just expanding and condensing a little bit easier. There's no substitution here. So it says use the product rule to expand each log expression. A says log base B of 9 times 5. So it starts as a product, which means when we split it, what happens? We add log base 3 of 9 plus log base 3 of 5. Can any of that be simplified? Is there a power I can raise 3 to get it to be 9? Yes, that becomes 2. Is there a power I could raise 3 to become 5? No, that stays the way it is. So unless it says like use change base to go further with this, I leave it the way it is.
Ms. Chrisweiser?
Yes.
I have a kind of a general question. I've always wondered this. Let's say, for example, log 3, like log base 3, 9. Is that 9 a power of the 3, or is it just a regular number?
It's so this is read as like what, so 3 is the base, right? So if I convert it to exponential, right? Let's say you don't see it right away. I don't know what that is. I'm going to set it equal to x. 3 to what power gives me 9 is the question. So 9 is the result of raising 3 to some power, and your job is to figure out what power.
No, my question is not like.
It's not
more
its
like,
exponent.
How do I write it?
Oh, so if you're
Is the
actually,
9 on the same level as the log, or is it
Yes.
higher or lower?
it's same level. So,
Okay.
so 3 is called subscript, 3 is lower, but 9 is same level.
Okay.
All right, how about B? When I split this, it becomes what?
Oh, you add to.
Add again, log 1,000 plus log x. Can either of those be simplified? What's the base on that log? 10. Can I raise 10 to a power to make it 1,000? The easiest thing with 10 powers of 10 is count the zeros of your answer. This is 3 plus log x.
So you don't use the calculator.
Nope. Okay, C. Now I've got a quotient. How do I split a quotient?
You
Subtract. So log base 5, 25 minus log base 5 x. Can either of those be simplified? Which one?
25.
Good. Becomes
2.
good. Ooh. D. ln's still a log, so all the properties still apply, right? This becomes subtraction first. ln of e to the third minus ln of 8. Then what?
can simplify ln and e.
So what does ln of e to the third become?
3.
3. So this can be done this way. Or the 3 bumps to the front. ln of e becomes 1. Still the same answer. So whichever way your brain sees it, go with it as long as it gives you the right answer. Still good?
Miss Chris Weiser,
Yeah,
can you zoom out to C, please?
sure.
Okay, thank you.
You're welcome, Taylor. Okay, example 5 says use the log properties to expand each expression as much as possible. So for A, they have an exponent. That exponent's going to get bumped to the front, and then I'm going to remember that when I expand this, each of the expanded terms are also going to get that too. So now this is a product. So this becomes 2 log base b of x plus 2 log base b of the square root of z. The square root of z becomes an exponent of 1/2. So this becomes 2 log base b of z plus 2 log base b of z to the 1/2. And the 1/2 gets bumped to the front, canceling with the 2, and I end up with 2 log base b of z plus log base b. This should not be z, sorry, that should be an x. For B, now I've got again power, so it's going to go to the front, and then I've got a quotient, so log base 5 25 over y, split that, 3 log base 5 of 25 minus 3 log base 5 of y. 5 log base 5 to the 25 becomes 2, and then I get 3 times 2, or 6, minus 3 log base 5 of y. C is ln of 10 over e. It's a quotient, so it becomes ln of 10 minus ln of e. ln of e cancels, giving me its exponent, which is technically a 1. So this would be ln of 10 minus 1. And this last one, this becomes log 9 plus log square root 10. The square root becomes to the 1/2 power. Log base 10 of 9 equals the 1/2 gets, or not equal, sorry, plus the 1/2 gets bumped to the front. Log of 10, log base 10 of 10 becomes 1, and this becomes log 9 plus 1/2. You could have also simplified that log here. So if I had done log base 10 of 10 to the 1/2, this is going to cancel and give you that same 1/2. So either way, you should simplify it to be that log base 10 of 9, so you can just leave it as log of 9 plus 1/2. So again, working in reverse order, the sum becomes the multiplication, the subtraction becomes division, and the number on the front becomes the power. So we are condensing. Sometimes the directions say expand or condense. If you start with an expression that has 1 log, you're going to be expanding it. If you start with an expression that has multiple logs at the start, you're going to be condensing it. All right, so write as a single log or condense. And again, it's going to say condense or expand at some point. These all have multiple logs, so I know I'm condensing. So A is a sum, which means it becomes a product. Yes. So this becomes log base 2 of 4 times the square root of x. So we're not simplifying this, we're just condensing it. It actually would have been simplified from the beginning if we were doing that. B, it's a subtraction sign, which means divide. Log 6x over 6, that we can simplify log of x. C, there's a power on there's a number being multiplied on the front, that becomes the power here. So I'd get log 3, 9 squared, there's a minus, so divided by 27, log 81, or log base 3, 81 over 27, which actually can get reduced, log 3, 9 over 3, or log 3, 3, which becomes 1.
The 2 only goes to the 9.
Correct.
Because it's only in front of the first one, right?
Correct.
Oh, okay. But if it was on the other one too, it would be to both of them?
Yep. And like think about how this eventually, because this said condense, we did it that way, but like all your properties of logs eventually overlap. If you were to simplify this from the beginning, this would be 2. Log base 3 of 9 is 2. Minus log base 3 of 27 is 3. 4 minus 3, which is 1. So 2 completely different ways to simplify this expression. And if it just said to simplify using any method, you could pick either one. This one I just condensed because that's what it said to do.
Right, okay.
All right, so D, both of them have an ln. This has a number on the front, so I'm going to bring it to the back as its power. It's addition, which means it becomes multiplication. Oh, x to the 5th, sorry. Thank you. And the order there doesn't matter. X to the 5th, x minus 2, that order doesn't matter.
So you wouldn't multiply?
No, you don't need to distribute. No. Extra work you don't need to do. If it was multiple choice and obviously that one was there, you would know that that was distributed, but you don't need to. Okay, so let me jump to this. Got multiple things in the denominator, and that's usually what throws people. Okay? So use properties of logs to expand. We're going back to expanding. Where possible, evaluate it without a calculator. So this has 1 log. I want to expand it to 2. Okay. Actually, not 2, 3. It would be log base 9 of 81. Now this means minus. Everything below that gets the minus. Because if I had separated out as a product, it would have been this. And then when I split that to a sum, they would have both ended up, that's a 9, oops, getting the negative. So you can kind of skip that middle step and just say anything in the denominator gets a minus. Anything in the numerator gets a plus. So denominator gets the minus. But am I done? No, there's 2 things I got to do. One is bump my exponent to the front. And there's also something else I can take care of there. What is it? Log base 9 of 81 is 2. Oh, I forgot the log on that. 9. Don't forget your bases. There's my end answer, okay? So think about this in reverse. If I had given you that answer and asked you to condense it, there's a positive, obviously, right? Well, I would have had to do it from here. It would have been from here, not the simplified. The positive log is my numerator. Both of those minus would go in the denominator. So if I have a sum and difference that has multiple parts, let's say I have log of x plus log of y minus log of z. The only one in the denominator is the z. Does that make sense? So this would be log x, y over z. If I have log of x plus log y minus log z plus log a, still the only one in the denominator is the z. Now the a is in the top. Does that make sense? Yeah? So be careful because it will expand it in different orders. But make sure if it's got the minus, it's in the bottom, and if it's positive, it's at the top. All right, folks. Have a fantastic day. I will work out that 1 slide of the extra examples on the video if you need it. Seniors, good luck tomorrow on your ACT. Get some sleep. The rest of you, homework's due Wednesday.